Good evening, dear participant, and I hope all of you are fine and doing well. First of all, I would like to check how many participant has joined. Please, can you reply in the chat box so that I can see your comment and I can start the session. Today I have only one system, so it will be very hard to check whether you are connected with me or not. I can see there are currently two viewers. Okay, no problem. We have to start. Okay. So today, as you know, we are going to. Good evening, Anthony. And yeah, okay. I'm very happy to see you here. Thank you very much. Johan Jose Amadu. Thank you. Okay, some viewers has been connected with us, and I'm very happy to see you. And I feel very sorry. Yesterday, I was not able to start the session due to we have a faculty development program was ongoing, and that time we got late to start this session. So that's why I have to postpone for today. I think everything is fine. I am proper audible to all of you. Okay, Anthony, Ania, please reply me if I am perfect audible to all of you. Okay. I think everything is fine. One more viewer has been connected with us. Lubem M. Kwagakar. Good day, and once again, good evening, all of you, and to join this session today. And today's session is very interesting because of we are going to start to cover new methods and a new area which will be very helpful to all of you in various way. Okay, thank you to reply here. I am perfect audible. Okay, now I feel very fine. Okay, so we have several topics related to the numerical methods which we will cover in this several lectures. Numerical methods play a crucial role in engineering discipline, providing essential tool for solving complex mathematical equations and analyzing engineering problems. So here are some reasons why numerical methods are important in engineering. These methods engineering problems often involve complex mathematical equations that cannot be solved analytically. Numerical methods such as numerical integration, root finding algorithm, and differential equation solvers enables engineers to approximate the solutions for these equations. This allows them to model and analyze real-world phenomena actually. Numerical methods offer efficient algorithm and techniques to solve engineering problems. They allow engineers to perform calculations and simulations in a fraction of the time it would take to solve them manually. This time-saving aspect is especially valuable when dealing with large-scale problems or iterative process. These methods help us in the handling non-linear system. Many engineers system exhibit nonlinear behavior, making analytical solutions extremely challenging or even impossible to obtain the solutions. Numerical methods provide a technique to handle non-linearities and iteratively converge towards approximate solutions. Engineers can simulate and analyze the behavior of complex systems accurately using numerical methods. Numerical optimization methods are widely used in engineering for finding optimal solution to design problems, whether it's optimizing the shape of an aircraft wing, the layout of a building, or the parameters of mechanical system. Numerical methods provide powerful optimization algorithm to determine the best design configuration based on specified criteria and constraints. So these are some features why we use numerical methods to find out the solutions or to solve various type of problems are in engineer and in other physical sciences also. We here in this session and in the coming sessions will deal some numerical methods which are very highly useful in engineering as well as physical sciences and applied to mathematics. These methods provide us an approximate solutions, not the exact solutions, but along with we need to analyze the difference between accurate analytic solution and approximate solutions. So there are several approaches to use this method, and these different methods we will cover in various lectures. Okay, so in this session you can see this is my MATLAB. You can see this is my MATLAB window, and along with I have okay, this is also very important. So in this session we will cover three methods. As you can see, here is Euler's method, then we have Heun's method, and at the end we will have these are three methods which we will cover here, Runge-Kutta method. And one more important thing I will let you know that we will not explain here about the methods, but we directly use this method how we can compute by using MATLAB. Otherwise, the lecture will be very long and I will not be able to cover these three methods. I include here four methods, but the fourth method, predictor corrector, is required one lecture specially. So I skip that one. Only we discuss about these three methods, and also we will compare these methods with the actual solution, analytical solution. Okay, so the first you can see here is Euler method. This one is y dash t is equal to fty. This is the first order differential equation, and with we have initial condition. So this equation can be easily reduced into in this form, in the form of iteration, recursive format. You can see here yk plus 1 is equal to yk plus h f tk yk. This is very quite simple. If we can choose see y tk plus 1 is equal to yk plus 1 and y tk is equal to we have yk. As we know, y dash tk will be equal to yk plus 1 minus yk upon approximately yk plus 1 minus yk upon and is equal to f tk and yk. So when we will simplify this part, we have yk plus 1 is equal to yk plus hf tk yk, and this is the corresponding initial condition. So when we are thinking about numerical solution of the above differential equation, we need to convert the given differential equation into the recursive format. Only then we are able to find out the solution. So the most important thing is we need to write the MATLAB code for only this equation. And you can see when we have k is equal to 0, when you will have k equal to 0 means we have this initial condition. And to get the solution, we need to apply here numerous iterations, and as we have more iterations, we have more accurate solution. And also one more important thing, we have to use at this place for loop. This is very important to let you know. And in previous lectures, we discussed all these conditional statements and the control, how we can control the flow, for loop, while loop, if else conditions, and etc. So for loop will be used to write the program for this equation. So now just we will deal with this equation, and we want to establish the program for Euler method along with this condition. So along with you can see the MATLAB. Yeah, here is I have already prepared the script file so that in less time I can be able to explain all these sequence of statements. So here only two things are important to understand. Here you can see the numerous statements are there. Okay, but for our program only the equation which I explained in the at this place, only this equation is required. Okay, so for this equation, how we can write the program, and along with we need to apply the condition for we need to apply the initial condition. Okay, see here, this is the that particular equation. The code for this equation yk plus 1 is equal to yk plus hf tk yk. Okay, see here. So this is the left hand side, y k plus 1 comma and colon. I will explain later about the colon. Just see here, this is the yk plus 1, then we have yk, then we have h, and then f-eval. This is inbuilt function in the MATLAB which will calculate, which will simplify, or which will evaluate the value of f. Okay, see here, this is f function. and f function has two arguments. One is tk and other is yk. So for that we will use f-able function. F-able function, as you can see, this is the function which is inbuilt function in the MATLAB, and this is the function f. Okay, and these are the corresponding argument tk and yk. Okay, so here you can see colon. Okay, here also you can see colon and colon. As you can see that y dash function depends upon two argument, y and t also. Okay, see once again the equation. This is the given equation. Okay, y dash t. Y dash t is function of t and y. Okay, so that's why when t argument will pass, only then we have the value of y. Y depends upon t. T is independent variable. Okay, you need to understand this point very carefully. Also, all the points which we will generate, we need to create a vector. Okay, so all those values when will pass at this place, this will take all the values of t when this for loop will execute. Okay, now see this for loop. So here is k is equal to 1 to n. N, how much iterations, how many iterations are required depends upon our solution. Okay, n equal to maybe 100, 200, 300, 400 and so on. So just consider under follow these three statements now. Okay, so when we have at this place k is equal to 1. Okay, so this will give us y2. This will give us y2. Here will be y1. Okay, and h Pavel, and here will be t1 and y1. Now the thing is how we will get the value of t1 and y1. Now this is the initial condition. Now note the point, when we want to use for loop, okay, this is the for loop, but we need to initialize, we need initial value. Okay, so this is the initialization. This is the initialization. So y1 means we have the initial condition, and initial condition is y naught. This is the y naught, and the value of y naught may be any value. Okay, depends upon the given problem, and according to that we will choose the initial value. Now this part is covered, which is given in our system or the differential equation. Now we need to establish a function that can be used for different functions. Okay, like here y dash t is equal to f t y t. So at this place we may have any type of function involving two variables t and y. So for that we are taking at this place f function. Now the value, now we need to calculate the value of h also. Okay, so see here t span. T span is the given interval for the time t. So here T naught is the initial value of the interval and this is the end value of the interval. So now to get the value of h, see carefully, this will give us the value of h, which is the step size. Understand, note this point very carefully. T span 2. T span 2 means value at this place. And T span 1 means this value. So this is TF minus T naught, and we will divide this by n. We may have any value. Here you can see we have n is equal to 100. Okay, and we have different value. So as much we have the small size, we have more accurate solution. We can increase or decrease this value according to our problem. Okay, so this will give us step size. Now we need T vector. T vector means just 1 minute. Yes. Okay. So this is the T vector. This will give us T vector. T span 1 means this value. T span 1 means this value. Okay. And 0 to n. So what this will produce? This will give us, if we have the interval 0 to 2, okay, so this will start from 0. This will give us the number of partitions of this interval. Okay, so suppose we have the value of h is equal to 0.01, then T vector will be equal to 0, then this value will be added 0.01, then we have 0.02 and so on until 2. Okay, we can check this value also. How we can do? Okay, see, if we have n is equal to 100, CLC, C in the at this place. We have n is equal to 100, and then we have T span 2. We will choose here T span 1 is equal to 0, and that of T span 2 is equal to, we have 2. Suppose these are the values of the interval. Interval we have is from 0 to 2. Enter. The value of h we have is, the value of h will be calculated by this formula. You can see this is the value of h, 0.02. Now, if we want to generate this vector, copy and paste at this place. So when you will enter, you can see this is the T vector. Okay, so all these value will pass through at this place. So this double dot will take all these values when the loop will work, because for each iteration we need the new value. Okay, so when we will have uh, when we have 0, okay, this is the first value, and when we have k is equal to 1, okay, so here we need the initial values. So for k equal to 2, k equal to 3, and new values from this place will be used at this place. Okay, and also if you can see the previous lecture for loop, this will help you in many ways, because here I am not able to explain completely the for loop, while loop, otherwise this will take more time. Okay, so this for loop will take all these values which will be generated at this place. Okay, this is the time vector. So these lines has been explained carefully. Now we want to convert this system of equations with initial condition, and we want to write the program which can be used anywhere for all type of differential equation. Okay, see, we can easily write the function involving, as we know, the function is involving two arguments. One is t and other is y. So this is the name of the function, ODE underscore Euler. We will save this function with this name. Okay, you will not change the name of the file. Note this point very carefully. In the previous lectures, all these things has been discussed very carefully. Now there are some arguments. One is the function. We need t span, interval for the time. This is the initial condition, and this is the n, which will give us the value of h. How many iterations are required to find out our solution? Okay, so here if Nargin, okay, so what is Nargin and V Nargin? See, yeah, what is Nargin? Number of input arguments, and sometimes we are using va varargin. Okay, this is the variable input argument list. How many variables are in the form of input argument? Similarly, we have targout. This will be number of output arguments, and similarly variable argot, that is the variable output argument list. So these are used to control. Sometimes we have the variables, how many variables we are using for our function. So these nargain, nargout, vargain, all these control the arguments and help us to run the program errorless. Okay, so see here, if nargain is less than 4, and this is the OR, n is less than and equal to 0 to n is equal to 100, and then end. If we are going to start the if condition, we need to end. Okay, so either nargain will be less than 4, or this will, we have n is less than and equal to 0 to n equal to 100. And for the initial condition also, we need to use at its place nargain is less than 3 when we have the initial condition. Okay, nargain is less than 3, so y naught is equal to 0, because this line contain two arguments, one is independent, another is dependent. Okay, so this is less than 3. Okay, so now this is the complete program for Euler ODE. Okay, similarly Similarly, you can come to the another program. This will help you. The previous one will help you to understand this Heun method. Okay. See here. For Heun's method, y dash a is equal to fty. The same method is here when we integrate on both sides in the interval tk to tk plus 1. In this interval, we will get uh, this part. Okay. And you can reduce this equation in this form. Ytk plus 1 is equal to, this will be in this side, becomes ytk plus integration tk to tk plus 1 fty dt with this condition. Okay. So now we will use at this place trapezoidal rule. So when you will use the trapezoidal rule at this place, this equation, this part will be reduced into this form. Yk plus 1 is equal to yk plus h by 2 ftk yk plus ftk plus 1 yk plus 1. Okay. So first we need to reduce the given differential equation in the form of iteration. And once you will write in this form, also further you can reduce, see here, yeah. So here you can see yk plus 1. This is from Euler method. So the above equation, by using this one, we can rewrite at its place, put this value. So this equation will be reduced into in this form. Now we need to write the program for only this equation. Okay, and this is very quite simple, as we do in the previous Euler method. Same parallel to that, we can easily write the program for this equation. See, these are same thing, only we change at its place the name of the method, which is Heun method. So ODE underscore Heun, and these statements are same, because we need not required to change anything. Okay, the change is only at this place, only at this place. So here you can see we have just 1 minute. Okay. So here you can see this is the equation number 1 and this is the equation number 2. Okay, so we need if you will directly use at this place, then it will be hard to use. So what we do here, we will divide this part of the program. One is we will write this program for this one in separate equation, and then for this in the other part, then we combine the whole method. Okay, see, this part is so here is first we are calculating fk travel ftk yk. Okay, this is the value of this part, only this part, as you can see. Then we will write for this equation. the complete. This is the first equation. So first equation divided in two parts. Then we will write the code for the second equation. This is the equation number 1. This is the equation number 2. This equation number 1 divided in two small parts. Okay, and if you want to write in the single line, you can do. There is no big issue. You can write this code in a single line as we do in the Euler method. Okay. So for this one, uh, see, this is the left hand side, yk plus 1. Then we have yk and h by 2 fk pavel, because now we need to calculate the value of this part here. Note this point very carefully. Okay. So in this way, we can easily simplify, we can write the code. And once you are able to write this code, only you need to understand this part. Okay. The other statements will remain same. There is no difference. And as you can see, the arguments for the function are same. F, T span, Y naught, N. So these three methods which we are discussing here are written for the same problem. We will choose here same problem and we will use these three methods to find out the solution graphically. If you want to find out the solution in the numerically, you can do. And yes, so now this method is also complete. You should note this code very carefully. You should note the code, this part also very carefully. Text are very fine. I have increased the font size so that all the content which I am presenting here are visible to all of you. But the code is very sensitive and you need to note each point very carefully. Now see, here we are talking about Runge-Kutta method. Yes. So one more thing I let you know that all these methods must be very familiar to all of you. Just I deal with the only computing part, how you can compute these results by using MATLAB. Okay. So my concern only the computing. So here is Runge-Kutta method, and this method is very familiar. Okay. So we have this equation. We will write the program for only this equation, and yk plus 1 is equal to yk plus h by 6 fk1 to fk2 to fk3 fk4, and fk1 is given by at its place. Fk1 will be equal to ftk yk, fk2 will be equal to ftk plus h by 2 yk plus fk1 h by 2. Similarly, we have fk3 ftk plus h by 2 yk plus fk2 h by 2, and here is fk4. So for this method, we have these four equations also, and for corresponding to each, we need syntax, how we can write these sequence of statements in MATLAB. And this is very quite simple. and many things are common. See, here you can see that here is, this is F1, this is F1. Okay, so for loop will be used there because iteration is there, and here we are using bargain. Okay, and bargain is used for variable inputs, variable input arguments. Okay, so we can start from this place. This is the functional statement. This is the functional statement, and we save this function with this name ODE underscore RK4. F is the function, T span, Y note, and var again. Okay, so the equation will be y dash t is equal to f t y t, same differential equation we have. So these statements will remain same. These are the same statements as you can see here. Okay, now for k equal to 1 to n, okay, and n is equal to 100 iterations are used at this place in first method, second method, and in third method. This is the value of f1. This is the value of f1. This code will deal with the equation number 1. Which one? For this only. This is the equation number 1. This is equation number 2. This is equation number 3. This is equation number 4. This is our final equation. Okay. See. So here we have H Faval, F, T, K, Y, K. These are the arguments. And one is how many variable input arguments are there. Okay. This is used here. So that if you want to remove, you can do. But this will sometimes will give us some error. So when you will use, this will control all the input variables. And F1 will equal to F1 colon dash. So this will convert in row vector. Okay. This we have a vector, and when you will take transpose, okay, so this will return us a row vector into column vector. Okay. Similarly, we will calculate F2. See this part only. See this part only, and you can easily compare with this statement. Here is ftk plus h by 2, yk plus fk1 h by 2. See here. Here is a function. This is t plus h by 2 and yk plus f1 by 2. Okay, this is the new value which will be calculated from this place. Okay, and h is already multiplied at this place. So here we are not using h. Note this point very carefully. Other things are same. So these will be converted into row vector. Similarly, we will find out the value of, we will write the script for f3 function. Then we will write the script for f4. Okay, and at the end, for this equation, yk plus 1 is equal to yk h by 6, fk1, 2fk2, 2fk3, fk4, and the corresponding script for the equation number 5, we have this one, yk plus 1 comma colon yk comma colon plus f1 plus 2 product F2 plus F3 plus F4 divided by 6. Okay, so here you three methods for Euler, Heun and Runge-Kutta method, fourth order. So these script file are prepared. Now we can check all these three method, and we will compare the results also. See here numerical results. Okay, so here what you can see, we have this is the differential equation. Y dash t is equal to 1 minus yt, and this is the initial condition. Y0 is equal to 0. The analytical solution of this differential equation we have is yt is equal to 1 minus exponential minus t. Okay, so this is the analytical solution. Now we have four solutions. One is analytical solution, three are approximation solutions by using Euler, Heun and Runge-Kutta method, fourth order. We want to compare these four solutions. Okay, so how we can do now? See, as you know, clear CLC, CLF, clear is used to clear all the variables from the workspace. This is the workspace, and there are several variables you can see and their corresponding values. So clear the workspace. CLC is used to clear the command window. Okay, CLC is used to clear the command window, and CLF is used to clear all the functions. Now here T-span. You can see in each method we have T-span. Okay, so this is the interval, and this will generate T vector as I shown you in the very beginning. Okay, so this is generated for the analytical solution. You can see this is the analytical solution. Okay, so for this one we generate T vector. Okay, and if you want to plot this analytical solution, we can do, and yt is equal to 1 minus exponential minus t. This is the analytical solution. As I told you that this is the analytical solution of this differential equation. You can find it, but here we just want to plot the analytical solution also. Okay, so now you can see here are some several statements. What about this statement? This will give us the graph of analytical solution. You can check all these statement in command window. Yes, this is CLC, and when you will paste in the command window and enter. So this is the analytical solution of the given differential equation. Okay, but and this is the exact solution also. Note this point very carefully. only the analytical solution have the exact graph. Other the numerical methods which we are using here give us only approximate solutions which are not the exact solution. Okay. Now, this is the differential equation which we want to solve. This is inline function. In the beginning, in the previous lectures, we discuss all about this, how we can write a function, inline function, function handling, okay, user-friendly function. There are several types. Here we are using inline function, which is very quite simple. Inline, and what about this one? Minus y plus 1 t. Y dash t is equal to 1 minus yt. Okay. So here I am writing minus y plus 1. Same thing. This part and this part you can compare. Okay. So this function involve two input variables. One is independent and other is dependent. One is t is independent variable, y is dependent. So in this way you can write this part. Okay. So this is the function which is on the right hand side. T is independent, y is dependent. And we want to solve this differential equation. Now, this is the initial value. Y naught is equal to 0 and n is equal to 4. There are 4 equations. Okay. So here what we do, here we are using ODE Euler. Okay. So here this is the function. Now compare this equation. Here is the function. Okay. And we want to pass at this place this function. This function. This is equal to f. Okay. So here we are call the function which we write at its place. We call this function, and corresponding to each argument we have to assign the values. This is the function which we call at its place. This is the input function which we want to solve. Okay. Then t-span is equal to, we have this one, 0 to 2 interval. Then we have y naught. Y naught is the initial condition which is 0, and n is in the beginning, it will be 4. Okay. But when you will see here, we have already assigned the value up to 100. So this will work for 100. Okay. So don't worry about this value. Similarly, we will call the function Heun. Only we will change the function Heun. Then we have ODE Runge-Kutta method. Okay. Other are same things. So this will give us the numerical values for by using Euler method. This will give us the numerical values for the differential equation. I remove this semicolon. Semicolon is used to suppress the statement, as I have explained many times. Yes. See. What you are observing here, this is the value of time from 0 to 2. Okay. And here is, these are the values of YE. YE means solution of the differential equation. Okay. These are the values of Y, numerical values. Okay. So similarly, you can check the other values. You can check this value. You can check this value for numerical results. But now we want to compare these values graphically. See this statement very carefully. Here is, we want to plot, okay, and we have 4 functions to be plotted here. These are 3 and one is this one. Okay, this already has been plotted. Okay, so here we can T1 and okay. Yes, see now carefully. This is one plot, and we are using here these 3 results by using Euler, Heun and Runge-Kutta 4th order. And note this point, the statement very carefully. T1YA, T1YA, the plot for this method will be plotted at this place, and the graph will be in green. G is the marker for the IH. This is the graph of the second method. Okay, and its marker is blue. Similarly, we have for third method T1YR by using the Runge-Kutta method, T1YR, and this is the, so when we will execute this sequence of statement, see, yes, so here you can see these are the 4 graphs. Okay, so dark blue is given by analytical method, dark black you can see, then we have green color, then we have blue and red. Okay, so red is used for Runge-Kutta, blue is used for Heun method, and green is used for Euler method. Okay, so this is the Euler method, and red is for Runge-Kutta method, and blue is for Heun method. So you can see the difference between these two. One more most important thing, if we increase this value, I want to change this value 100 and see again. So you can see at this place the difference of error has been reduced. So when we want to find out the solution by using numerical method, so to reduce the difference between the solution of the numerical method as well as analytical solution, we need to increase the number of iterations. So here you can see the the difference is very less. Okay, so difference is very less. You can increase, you can move in any direction. Yes. So when you will increase the number of iterations, all these graph will coincide with each other. Okay. See here, if I increase the number of iteration to 200 and run this program. Now there is all the three graphs are on the same line. Okay, all the graphs are coincide. Okay, so in this way you can put in the chat box in the live chat. Okay, I will try to justify you, and today in this session we are covering only one method. Please let me know my screen is visible. Go to my screen. In the chat box I am seeing that there are some questions that you are not able to see the screen. If some of the participants are not able to check the lecture, don't worry, the recording will be available there, and when the lecture will be over, after that you can listen again this lecture. Okay. Anthony Anaya, please let me know. I hope I am perfect audible. And all of you can see. If there is any error, please let me know. Gloria Damu, thank you to joining this session, and I hope you are new one. Okay, thank you. Thank you. The screen was visible. Okay, if you have any question, you can put in the chat box. Great. Okay, so the thing is, today in the session we will cover only these three methods. Difference in the coming lectures in the different methods. Once you are able to understand the script which I present here, how we can convert the given differential equations, converting into iteration, then we can easily for the same. And what are the syntax to write the program in MATLAB? Okay, so you must try these three methods, and in the coming session we will cover different methods, and all these will help you in many ways. So thank you very much to be part of this session. Okay, if you have any question, you can WhatsApp number. You can easily find my contact number on the website mttf.in, a website of this foundation, and also when you will go to the description of this YouTube channel, there is also we have provided you the WhatsApp number. Okay, so thank you very much to join this session today, and in the coming weekend I will come here with the new methods we have several sessions, especially on numerical methods. Okay, so